Good morning, student. Today we will start Unit 2 Solution, Lecture 1. Today we will discuss the solution, types of solution, and various methods for expressing concentration. So, what do you mean by solution? Definition of solution. Solution means homogeneous mixture. Remember, homogeneous mixture. Homogeneous mixture means composition and the properties of the solution are same throughout the mixture. Homogeneous mixture is composition and properties are same throughout the mixture. Now, mixture of what? So, generally, two or more than two components. Two or more than two components. If the solution having two components, then it is known as binary solution. Three components, then tertiary solution, four components, quaternary, and so on. In short, minimum two components is required. Reason solution is a mixture. So, which two components is required? So, one component is solvent and second component is solute. That means solvent. One component is solvent, second component is solute. That means to prepare solution, solvent and solute is required. Minimum two components. Solvent means generally the component which is present in large amount. That means in large amount. Otherwise more amount. In large amount present in solution. Present in solution. Solute means the component which is present in less amount. Less amount. Present in less amount. Which is known as solute. In a solution, always solvent is one. That means which is present in large amount, otherwise more amount. So always solvent is one. But there is a possibility of more than one solute. Solvent is always one. Therefore, physical state of the solution depends upon the physical state of solvent. That means, remember, physical state of solution depends upon physical state of solvent. That means physical state means solution are solid, liquid and gaseous solution. That means suppose solvent is solid form, then also solution will be in solid form. So based on physical state of solvent and solute, we can classify solution into three categories: solid solution, liquid solution and gaseous solution. That means types of solution. Types of solution based on physical state. That means physical state of solution. Physical state of solution. Again, physical state of solvent. Physical state of solute. And finally, example of such type of solution. Now, physical state of solution, that means three types. That means first is solid solution. Now, second one is liquid solution, and the third one is gaseous solution. Solution is solid. That means physical state of solvent is solid. Now, physical state of solid, so it will be changed. It may be solid, liquid, or gas. That means physical state solid, liquid, and gas. Physical state of solvent is solid. Reason, solution is solid. Physical state of solution depends upon physical state of solvent. Again, liquid solution, that means solvent is in liquid form, liquid. Solid may be in solid form, liquid form, again in gaseous form. Now, third types, gaseous solution. The compulsory solvent is in gas form. And the solid form, liquid form, and gaseous form. The three types of solution, solid, liquid, and gaseous, based on physical state, they can be classified into 9 categories. 3, 3, and 3. Total 9 categories. Now, taking the example of solid solution. Now, solvent is solid and the solute is solid. That means this example is amalgam. Otherwise, we can write solute is in liquid form. That means here example is here. Both are solid form. That means base example of alloys. That means copper and gold. So example we can say alloys. Okay. Alloys is an example. Copper dissolving gold. Now solute is in liquid, solvent is solid. So here example is amalgam means what? The mixture of metal with mercury. That means amalgam of sodium. We can say sodium amalgam. Sodium amalgam means mixture of sodium and mercury. Suppose zinc amalgam means mixture of zinc and mercury. Here physical state of solvent is solid. That means sodium is solvent and mercury is solid. Now, physical state of solvent is solid, physical state of solid is gas. That means we can say the substance which can dissolve gaseous substance in solid substance. That means this example is catalytic hydrogenation. That means H2 in palladium. That means hydrogen is in gaseous form. Palladium catalyst when hydrogen gas is absorbed in palladium catalyst. Palladium is in solid form. that means it is solvent, hydrogen in gas form, that means solute. Now liquid solution, that means solvent is liquid, solid is in gaseous form. So simple glucose is solute and water is solvent. That means glucose dissolved in water. Now both are liquid. So ethanol is solute, which is in present liquid form, dissolved in water. So ethanol plus water solution. Now solute in gaseous form, solvent liquid. That means oxygen plus water. Oxygen dissolved in water. Now gaseous solution, that means solvent in gaseous form, solid in solid. That means the substance which can having sublimation property, that means solid is directly converted to gas. We can write such type of example here, that means camphor. Okay, mixture of camphor in air, otherwise we can say here N2 gas. That means solid to. Now again liquid. Solute is in liquid form. That means the liquid which having very high vapor pressure, that means volatile property is more volatile. That means direct converting to gas. That means we can here write chloroform. Chloroform in N2 gas. Chloroform is a more volatile substance present in liquid form, but due to more volatility it is converted into gas. Now both are gas form, that means oxygen plus nitrogen gas. That means oxygen mixed with N2. These are the classification based on physical state of solute and solvent. Solution can be classified into three categories. These are all binary solution. Binary solution means having two components. And generally, as per syllabus, we are studying binary solution. That means one component is solute and second component is solvent. Now, when the solution is prepared, then we have to calculate composition. Composition of solution, that means composition. The composition of solution can be expressed in terms of concentration. Composition of the solution can be expressed in terms of concentration. Now, composition based on concentration, that means we can express by qualitatively as well as quantitatively. That means concentration qualitatively and second one quantitatively. Qualitatively and quantitatively. Qualitatively means generally into two categories. Dilute solution and second one is concentrated. Dilute solution and concentrated. That means we cannot calculate the amount of solute which is present in solution, but based on property. Dilute solution means less amount of solute is present, less amount of solute. That means solvent is more and amount of solute which is dissolved is very less. Concentrated solution means amount of solute is more. More amount of solute is dissolved. More amount of solute is dissolved. Suppose in 100 gram solution, 0.5 gram solute is there, otherwise 1 gram, then it is known as dilute solution. But suppose in 100 gram solution, 40 gram solute is dissolved, 50 gram solute is dissolved, 60 gram, then it is known as a concentrated solution. That means amount of solute which is dissolved is high. Based on qualitative analysis, only we can say dilute solution and concentrated solution, but we cannot calculate exactly what will be the amount of solute present in solution. Therefore, we have to require quantitatively measurement of the solution. That means when concentration expressing quantitatively, then we can calculate exactly what will be the amount of solute present in solution. So now we are discussing various methods of calculating solute. That means quantitative method for the calculation of solution. We are discussing various methods for expressing concentration quantitatively. The first method is percentage method. Percentage of the solute can be expressed in various ways. Mass percentage, volume, again mass by volume. The first is mass percentage. Mass percentage. So how to calculate mass percentage? So mass percentage of component. That means we have two components generally in binary solution. So mass percentage of component means mass of component. Mass of component divided by total mass. Total mass of all the components present in solution. That means total mass of solution multiplied by 100. Then we can easily calculate mass percentage of component, whether it is solute or solvent. Suppose example 10% glucose solution in water. Okay, 10% glucose solution in water, that means W by W. Mass percentage means W by W. Symbol is W by W. That means 10 gram glucose is dissolved in water and make the solution 100 gram. Make the solution in 100 gram. That means 100 gram solution is taken, then in this 10 gram glucose is there and 90 gram water is there. So mass percentage. Second example is bleaching solution, commercially used bleaching solution, which is actually 3.62%. W by W, that means sodium hypochlorite. Sodium hypochlorite solution is there. percentage W by W, that means mass percentage. Now second one is volume percentage. Volume percentage means V by V. So by same manner, instead of mass we can use volume. That means volume percentage of component is equal to volume of component divided by total volume of all the component. That means we can write volume of solution. Volume of solution into that. Generally, solid and solvent both are in liquid form, then volume percentage method is used. So example, 10% V by V ethanol solution. Ethanol solution in water. That means aqueous solution. When solution is prepared in water, then it is known as aqueous solution. And other than water is solvent, then it is known as non-aqueous solution. So 10% V by V ethanol solution is 10 ml. 10 ml ethanol is taken. 10 ml ethanol is taken and add water in 10 ml ethanol, so that solution becomes 100 ml. Solution becomes 100 ml. That means in 100 ml solution, 10 ml ethanol and 90 ml water is present. One base example is ethylene glycol. That means 35% V by V ethylene glycol solution. Ethylene glycol solution in water. That means this solution is used as an antifreeze solution. Antifreeze solution in car and other vehicles. That means this solution decrease the freezing point of water. Freezing point of water is 0 degrees Celsius, but this solution decrease from 0 degrees Celsius to down around minus 70.6 degrees Celsius. Here 35% V by V solution is 35 ml of ethylene glycol dissolved in water such that the solution volume having 100 ml. Now third method is percentage mass by volume. That means mass by volume percentage. That means W by V. The simple representation. Percentage W by V of solute. The mass of solute. Mass of solute. Generally taken in gram divided by volume. Volume of solution. Volume of solution is ml. Okay. That means 10% W by V anyways aqueous solution. That means take the 10 gram of anyways and dissolve in water in 100 ml. That means 10% W by V NaOH solution is 10 gram NaOH is present That means definition is amount of solute in gram dissolved in 100 ml solution. Amount of solute dissolved in gram in 100 ml solution is known as percentage W by V, otherwise mass to volume percentage. Now fourth one is mole fraction. Mole fraction of the component can be calculated simple. Mole fraction of component equal moles of that component. Moles of component divided by total moles of all the component present in solution. Total moles of all the component in solution. That means suppose we have a binary solution. That means two component binary solution. Two component A and B. One is solvent and second one is solid. Then mole fraction of A, how to calculate? Mole fraction means generally symbol we are using X. So Xa equal to can be calculated moles of A, that means Na divided by Na plus Nb. Similarly, Xb can be calculated as Nb upon Na plus Nb, that means total mass. And remember, addition of the mole fraction of all the components present in solution is equal to 1. That means Xa plus Xb equal to 1. Suppose more than 3 component, 4 component, in short, addition of mole fraction of all the components present in solution equal to 1. Now, fifth one is ppm. ppm is parts per million. Parts per million. So ppm of component. ppm of component. So how to calculate? So parts of component. Parts of component divided by total parts of component in solution. Total parts of component in solution into 10 power 6 into 10 power 6. When concentration is expressed in ppm, so when the amount of solution is dissolved is very less, that means trace amount of solute. Trace amount of solute. Say example, O2 dissolve in seawater. O2 dissolve in seawater. Otherwise, various pollutants present in atmosphere also can be expressed in ppm. That means when solid is present in very less amount, then ppm method is used. ppm can be expressed in 3 ways. One is mass to mass. Mass to mass ppm. Second is volume to volume ppm. And third one is mass to volume ppm. Mass to mass ppm means mass of the component divided by total mass of all the component in solution into 10 power 6. Volume to volume ppm means volume of the component divided by total volume of the component in solution into 10 power 6. Now when we expressing ppm, mass to volume, that means we have to take the mass of component and divide by total volume. That means for that, remember how to calculate ppm. So ppm can be calculated simple for mass to volume. Mass of component divided by volume. That means mass is taken in milligram and volume is taken in liter. Mass is taken in milligram and the volume is taken in liter. Otherwise, mass is taken in microgram and the volume is taken in ml. That means 1 ppm, remember, 1 ppm equal to 1 milligram per liter. Otherwise, equal to 1 microgram per ml. Microgram per ml. That means mass is taken in microgram and volume is taken in milliliter. Then also we can calculate the ppm. Now 6th one is molarity. Molarity means capital M. The simple definition is that molarity. How to calculate molarity? So moles of solid divided by volume of solution. Volume of solution. Volume of solution in liter. Suppose example, we have 2.5 molar NaOH aqueous solution. That means 2.5 moles of NaOH dissolve in 1 liter solution. 1 liter solution. 2.5 moles means 2.5 into molar mass of NaOH is 40. That means this gram. That means 100 gram. 100 gram solution is dissolving here. That means 2.5 into 40. That means 10 gram. 10 gram NaOH. 10 gram NaOH is dissolving 1 liter solution. 10 gram. Moles into molar mass. Now 7th one is molarity. Molarity. Molarity means small. Molarity equal to moles of solid. Moles of solid divided by mass of solvent. Mass of solvent in kg. That means definition of molarity means numbers of moles of solid dissolved in 1 kg of solvent. Definition of molarity means same, but here volume base is there. That means numbers of moles of solid dissolved in 1 liter solution. Here 1 kg. Say example, 1 molar NaOH aqueous solution is there. We are taking bismuth, okay, 2.5. We can decide exactly difference. So 2.5 moles. Here also 2.5 moles. So 2.5 moles of Na is dissolved in here 1 liter solution is there, and here dissolved in 1 kg solvent. That means here solvent is water, aqueous solution, so in 1 kg water. That means in 1000 gram. Mass is same. 2.5 moles means 2.5 into 40 gram. Okay? Gram. Same as. That means 10 gram. But it is dissolved in 1 kg water. And here 10 gram is dissolved in water such that the volume of solution becomes equal to 1 liter. Here it is dissolving 1 kg of water. So mind this difference, keep into mind this difference. Now each unit of concentration having advantage, disadvantage. Generally, we considering the effect of temperature. We know temperature having effect on volume. Temperature affect the volume. That means the concentration unit which depends upon volume are changes by changing the temperature. Temperature depends upon volume. That means units of concentration changes. That depends upon volume. Now considering this is mass percentage, it does not depend upon volume, so it does not change. Now volume percentage that depends upon volume changes. Again percentage W by V depends upon volume, the changes. Mole fraction, here there is no volume, so it does not change. Now ppm, so mass to mass does not change. Volume to volume depends upon volume changes. Mass to volume also changes. Molarity, volume is there, that means changes. Molarity, no volume, so it will not change. So in short, temperature affect the volume, it does not affect the mass. That means unit of concentration that depends upon volume are changes by changing the temperature. So these are the basic formula for expressing the various concentration unit. Remember this formula for further calculation.